Welcome to another Geography 215 math video. This is the math video for Chapter 6. The learning objectives for this video are to learn about relative humidity and to learn about saturation air temperature. Let's start with relative humidity. Relative humidity is determined by how much you have divided by how much the air can hold at a particular temperature. The basic concept holds true for all of the measures of moisture in the atmosphere discussed in the section, How Humid Is It? In doing the mathematics, you will initially get a decimal value and then need to convert this to a percentage. Let's start with the question. Can you select the key words in these problems? Read these problem statements and circle the key words, then provide an explanation of what those words are telling you in reference to the problem. Look at the boxed problems on the slide and see if you can see the keywords. The keywords are bold and underlined. For the first problem, air is descending down the leeward side of the mountain. Calculate temperature at the base of 1,000 feet. Descending air temperatures are always calculated with the wet adiabatic rate, and the air parcel is warming. The second problem, the air temperature is 10 degrees Celsius and it is foggy. What is the dew point temperature? Fog is one type of cloud. If a cloud has formed, the air has cooled to the dew point, which is then 10 degrees Celsius. When the dew point temperature and air temperature are the same, the air is saturated, and thus a cloud may form. For the third problem, the relative humidity is 100%. Determine the level of saturation of an air parcel. These notations are saying the same thing. Saturated air can hold no more moisture, so the level of saturation is 100%. And lastly, a saturated parcel of air reached the dew point at 9 degrees Celsius. What is the air temperature? See the response to be above. The thinking process is the same. Now let's mathematically calculate the relative humidity. For these three problems, calculate the relative humidity percentage for the following. Remember, the relative humidity equation is relative humidity equals vapor pressure over saturation vapor pressure. So the first problem asks, vapor pressure equals 6 millibars. Saturation vapor pressure equals 12 millibars. What's the relative humidity? The relative humidity equals the vapor pressure over saturation vapor pressure. In this case, 6 millibars over 12 millibars, which equals 0.5. To get a percentage, you times it by 100. 0.5 times 100 equals 50%. Therefore, the vapor pressure equaling 6 millibars and the saturation vapor pressure equaling 12 millibars gives you a relative humidity of 50%. For the next problem, the mixing ratio equals 5 grams per kilogram. The saturation mixing ratio equals 9 grams per kilogram. What is the relative humidity? Relative humidity equals vapor pressure over saturation vapor pressure. In this case, it's 5 grams per kilogram over 9 grams per kilogram, which equals 0.56. To get a percentage, we times it by 100. Therefore, we get 0.56 times 100, which equals 56% relative humidity. With a mixing ratio of 5 grams per kilogram and a saturation mixing ratio of 9 grams per kilogram, you get a relative humidity of 56%. The last question has a mixing ratio of 10 grams per kilogram and a saturation mixing ratio of 10 grams per kilogram. What's the relative humidity? Relative humidity equals vapor pressure over saturation vapor pressure. In this case, 10 grams per kilogram over 10 grams per kilogram, which equals 1. To make it a percentage, you times it by 100. 1 times 100 equals 100%. With a mixing ratio of 10 grams per kilogram and saturation mixing ratio of 10 grams per kilogram, the relative humidity equals 100%. We have now solved 3 relative humidity problems. Don't be afraid to pause this slide or go back if you need to review these problems. Outdoors, the air temperature is 10 degrees Celsius, or 50 degrees Fahrenheit, and the relative humidity is 65%. What is the relative humidity of the air if it is drawn indoors and heated to 25 degrees Celsius, or 77 degrees Fahrenheit? Assume that no water vapor is added to or removed from the air. To solve this problem, follow the steps that are in the box. First, from the table 6.4, determine how much moisture the air can hold at 10 degrees Celsius. At 10 degrees Celsius, the air can hold 12.27 grams per kilogram of moisture. Next, calculate what 65% of A, remembering that the outside air has a relative humidity of 65%, this value of A. So you take 0.65 times 12.27 grams per kilogram, and you get 7.98 grams per kilogram. Now, from table 6.3, determine what the air can hold indoors at a temperature of 25 degrees Celsius, which is value B. At 25 degrees Celsius, the air can hold 31.67 grams per kilogram of moisture. Last, divide how much moisture is in the air going into the room, 65% of part A, by how much the air can hold in the room, which was part B. Remember, relative humidity is expressed as a percentage. So now take 7.98 grams per kilogram over 31.67 grams per kilogram, which gives you 0.2518, times that by 100, and you get about 25%. Therefore, you would answer this problem with 25% relative humidity. Let's try another problem. This is math thinking of ratios. Remember, relative humidity is a ratio in comparing how much moisture the air contains to how much moisture the air can hold at a particular temperature. Again, this process is on the exam. Refer to Figure 6.7 and Table 6.3 for this question. If the relative humidity is 84% and the vapor pressure is 12 millibars, what is the vapor pressure at saturation? Hint, the equation is how much there is, 12 millibars, how much the air can hold at the temperature. The value calculated would be 84%. What you need to do is set up the equation. Now manipulate the variables to solve for what the question is asking for. So in this case, we would take 12 millibars over 84%, or 0.84, which gives you 14.26 millibars. Moving on to the next question, what is the approximate air temperature? Hint, go to figure 6.4 and locate the value just calculated on the y-axis, as this is what your blob of air can hold if saturated. Read across to the black curve. This is the saturation curve. Once at the saturation curve, read down to determine the air temperature in plus or minus 1 degree Celsius. So this would be across from 14.26 millibars over to the black saturation curve, then read down to 12.5 degrees Celsius. The last question we're going to go over today, question 5. Refer back to table 6.3. Again, this process is going to be on the exam. The air temperature at sunrise is 5 degrees Celsius with a relative humidity of 85%. The air temperature reaches a maximum of 15 degrees Celsius at 4 p.m. Assuming that the moisture content has not changed, predict the relative humidity later in the day at 4 p.m. Question 5. refer back to Table 6.3. Again, this process is on the exam. The air temperature at sunrise is 5 degrees Celsius with a relative humidity of 85%. The air temperature reaches a maximum of 15 degrees Celsius at 4 p.m. Assuming that the moisture content has not changed, predict the relative humidity later in the day at 4 p.m. Here's your practice space. Let's look at the steps to help solve this problem. How much moisture can the air hold at 5 degrees Celsius? Now, after figuring that out, you have to determine what 85% of this is. Next, how much moisture can the air hold at 15 degrees Celsius? Once you figure that out, now you have how much the air had and how much it can hold at the afternoon temperature. We will have to divide and determine the afternoon relative humidity. Now let's do some work to figure out this problem. How much moisture can the air hold at 5 degrees Celsius? It can hold 8.72 millibars. Now you must determine what 85% of this is. So you take 8.72 millibars and multiply it by 0.85, which represents 85%, and that gives you 7.412 millibars. How much moisture can the air hold at 15 degrees Celsius? That is 17.04 millibars. Lastly, now that you have how much the air had and how much it can hold in the afternoon, do the division and determine the relative humidity. So you take 7.41 millibars and divide it by 17.04 millibars, which gives you 0.435. Converting it to a percent, it gives you 43.5%. Therefore, your answer to this problem is 43.5% relative humidity at 4 p.m. This ends the math video for Chapter 6. As always, please let me know if you have any questions. Have a great day.